Hi everyone. So the objective of our project is to test whether a supervised random walk algorithm proposed by Backstrode and Kovacs can improve the performance of the recommendation system of Tencent Microblog. And our dataset include information about the connectivity among users, include no feature and edge feature, and also include a recommendation log file which indicate whether a recommendation is accepted or rejected by the user. And the biggest challenges for our project is the size of the data. And we come up with several approaches to address this issue. Well, the first one is that we adopt a simplified version of the original algorithm. So the original algorithm defines an objective function. And based on the no feature and edge feature, the algorithm will keep calculating different versions of edge strengths until it minimizes the objective function. And it is a very sophisticated algorithm, but the problem is that even though after we pick a sample from the network data, each iteration still run more than 1 hour. So it's not practical. So in order to reduce the running time, that we adopt a simplified version of algorithm. So we use a logistic regression and take no feature and edge feature, and then generated an edge strength. And the edge strength only calculated once. So as a result, we can save a lot of computational time. And here is the approach that we have. So we first process the data, extract the feature, run the regression, and then run the random walk algorithm. So for the data processing stages, we pick the most recent 1000 record in a recommendation log file, which would be used as the test sample. And in the connectivity data table, that we only include those nodes that is less than or equals to 4 steps to those nodes in the text sample. And then based on this node that we select from the network, that we extract no feature and edge feature. And then we put the whole thing into the logistic regression in order to generate the edge strengths, which would serve as the input of the random walk. And we also use a spectral version of logistic regression in order to address the problem of unbalanced outcome, which means we have most of our connection record means there's no connection between the node. And then we put the edge strength data into random walk in order to calculate the node score. And since we have already discussed the random walk algorithm in the class, that I'm not going to discuss this in detail, but just mentions that in order to calculate the node score, we have to construct a probability matrix, which is the n by n matrix, and n is the number of node score. And the problem is that if the probability matrix has a lot of empty cells because most of the node is not connected. And if we are using the traditional matrix calculation to implement the random walk algorithm, that the running time depends on n squared, in which n equals to the number of nodes. In this case, the algorithm has to go through all the cells in the probability matrix, but since most of the cell in the matrix is 0 and does not contain any information, it wastes a lot of computational resources. So the solution is to compress the matrix into a 3-dimensional array, while the first two column indicates the starting node and the ending node, and the third column represents the probability. So each record in this array contains information. And another modification is that since we still have 300,000 edges. So basically, for most of the personal use computer, they don't have the memory, a big enough memory to handle arrays is that big. So another modification that we implemented in the algorithm in the code is that we cut this giant big area into multiple chunks and then perform the calculation in this small chunk. So it could be fit into a small memory. But unfortunately, in order to reduce the computation time, the simplification of model also significantly reduce the performance of the model. So we could see that the ROC curve of the random walk algorithm is actually lower than the random classifier. So the conclusion that we got from this explanatory study is that we may need to actually train a model on an entire data set, because we suspect that the poor performance of the current model is probably caused by the loss of connection information while we're doing the sampling. And for the next step, we're also considering revise the original algorithm by changing the global random walk to a localized random walk in order to save the calculation time. And we are also considering use other technique more similar to the collaborative filtering, and maybe there would be a good alternative as the recommendations